Hey guys, welcome back. We've got an example here of the formation constant. So we got ammonia. Excess ammonia, and it happens to be 0.04 molar ammonia. Copper, 2 ions form a deep blue complex ion, which has a formation constant here, 5.6 times 10 to the negative 11th. 10 to the positive 11th, excuse me. Make sure that we can see that. Calculate the concentration of copper 2 in solution by having 0.5 moles of copper 2 in half a liter. All right, so we have 0.005 moles of Cu2 plus. We don't care about the sulfate. 0.500 liters gives us 0.010 molar Cu2 plus. All right, so we have Cu2 plus in solution with ammonia, 4 of them, and I want to do it this way. Make that 4 pop to make a complex ion of CuNH3 4 2 plus. And then Kf is huge, right? So the Kf expression is equal to CuNH3 4 2 plus all over Cu2 plus and NH3 to the 4th power. All right, ice table. We would have 0.010 molar. We have 0.40 molar, and we have nothing. Well, subtraction, minus 0.010 minus 4 times 0.010 plus 0.010. So I have none. That's 04, that's 0.36 molar, and 0.010 molar. All right. So what do we have then? Is the question 0? Well, if I ask my math people, can I have 0 down there? Can that be 0 and still be in equilibrium in the solution? No, it cannot be. So we have to assume a small back reaction. All right, so we're going to flip the reaction. So if I flip the reaction, all right, what happens? We would have Cu NH3 4 2 plus. I'd have Cu2 plus 4 NH3. Now Kf, or K, would be 1 over Kf, right? Which 1 over Kf is let's call it 8 times 10 to the negative 12. And that K, that is going to be then Cu2 plus NH3 to the 4th all over Cu NH3 4 2 plus. All right, another ice table, your favorite. So our concentrations, we had 0.010, nothing, and 0.36. Minus x plus 4 plus 4x. And so we'd have 0.010 minus x, and 0.36 plus 4x. Plug them in. 1.8 times 10 to the negative 12 equals x times 0.36 plus 4x to the fourth, all over 0.010 minus x. Now, what can we do here? Right? What can we approximate? The change. That's going to be 0. That's going to be 0. Which makes it really nice because we didn't want to have to solve x to the fourth here. So approximating, this becomes 1.8 times 10 to the negative 12 equals x times 0.36 to the fourth all over 0.010. All right. And so what does that become? All right. That means we get 1.8 times 10 to the negative 12, right, times 0.010 divided by 0.36 to the fourth equals x. So x, which equals our copper ion, is what? Let's see. 1.8 times 10 to the negative 12 times 0.01 divided by 0.36 to the fourth. Oh, I did error. I get 1.1 times 10 to the negative 12 molar, which that doesn't seem very big, and it shouldn't be very big, right? It should be very small. So that works. However, if you think about it, it's still a lot of ions in a liter, because if you have 1 liter, you have 1.1 times 10 to the negative 12 moles. And that would be like 6.6 times 10 to the what? 10 to the 11th. So you still have 6 times 10 to the 11th, almost 7 times 10 to the 11th copper ions in a liter. That's a lot of copper ions, if you think about it. I mean, very small concentration, how we talk about concentration of ions, but it's significant. All right, so that's how we do that. So let's recap real quick. What did we do? What did we go through here? Right? We found the original solution of copper, right? How much copper there was. And then we added ammonia and to make this new complex ion with the formation constant. And because it's so big, 5.6 times 10 to the 11th, we assume it pretty much all goes. However, it can't all go because that's still there. So we flipped the reaction. There's a way to do it without flipping the reaction, but we did it with flipping the reaction because that's what our book's doing. And so we flipped the reaction. K is 1 over K now, which is a much smaller K, right, which is what we expect. And we did another ice table to do the back reaction. Remember, you got to keep in count of these. And we just did the equilibrium constant like we've always been doing, approximating and everything. X happens to be copper 2, which is that. All right. I hope that works for you guys. If you have any questions, reach out. Otherwise, we'll see you next time. Take care.